Starts on page 498. Okay, so when we look at these two things that we're going to graph, tangent and cotangent, they're a little bit different than our sine and our cosine waves. Okay, they're not putting the hand out the window anymore. They're not going this way. All right, when you're driving. Now we're going a little bit different style. How you're going to see them are going to look familiar to you as far as when you had your sine and cosine ones. It's going to be just like before. The only difference is we've got tangent and cotangent in there instead of sine and cosine. Now, a couple things that you'll need to know as far as how and what things do with them. We will not have an amp necessarily like we had for the other two, but we will have a period still. And the period this time for both of these is going to be pi divided by the absolute value of b. That's a b, not a 6. Okay? So it's the absolute value of b. If I can make it look more like a b. All right? Now the other thing that we're going to have in here is what we call a vertical asymptote. And what a vertical asymptote is like those amp lines that I drew where it was like the boundaries. That's what the asymptote is going to do for you. It's going to be a boundary line for you. Okay? For these, each of them have their own special or own specific one. Okay? For the vertical asymptote, it's pi divided by 2b, or not 2b, when it's tangent. So I'll put that underneath it. And it's pi divided by the absolute value of b when it's cotangent. So notice the difference between them. One's a little bit different than the other. And we'll explain more when we go to graphing, okay, and how that actually works. Okay, so again, it's 2b, or just b, not 6. First hour I thought that was a 6, and they were wondering why it was certain numbers in there. Now notice the one thing that you won't see is you won't see an amp. Okay, we are going to discuss the amp as a vertical stretch or vertical shrink, just like we had before. But that's all it's going to do is just whether how far up or how far down we go. Okay, so we don't have to necessarily say what the A is for that. Okay, so what you're going to see for these, just so that you know, you're going to have something like this. G of x is equal to 2 tangent of 3x. Okay? So, first things first, just like we had on the other ones, I need to know what the period is. What's the period? What number's in the B position? 3. So I take pi divided by the absolute value of 3. What's the absolute value of 3? 3. Good. Now, because this one's tangent, not cotangent, okay, now in order to find my vertical asymptote, I'm going to abbreviate that as VA, just so that way I don't have to write as many words, because you know how I am when I write. It's not very clear. So VA is going to be what I call the vertical asymptotes, not to be confused with Veterans Affairs, Mr. Severson. But for that particular purpose, VA is going to be my vertical asymptote. Okay. So again, if I put that in my formula, I've got 2 times the absolute value of 3. What's the absolute value of 3? And 2 times 3 is 6. Okay. All right. Now, when we go to graph these, unless I shift it left or right, up or down, which I have not done any of that, because you notice there's no adding or subtracting in the problem, the vertical asymptote is going to be pi over 6 units away from the origin. So I'll put that in orange so you can see it. And all I do is I just put pi over 6 here. As long as it's labeled, everything's good. If I go pi over 6 to the right, I also have to go pi over 6 to the left. So that's going to be a negative pi over 6. Okay? And what I'm going to do to set up boundaries is I'm going to just make dashed lines going up and dashed lines going down. Is everybody okay with how I got those two things? Okay? We okay with that? All right. Now, from here, the next thing that I need to know from there is, where is it going to cross? What's it going to do? This is not going to be a wave like sine and cosine or you sticking your arm outside the window when you're driving. Okay? It's going to go up or down depending on whether it's tangent or cotangent. So for this particular thing, then, what I need to do next is I need to cut a sixth in half. Okay? What's a half of a sixth? What?
No, not at all.
Yeah, 1/12. Good. Okay, and again, if you remember from what we did for sine and cosine, all we're basically doing is taking the 1/6 and multiplying it by 1/2. Or, if you want to put it easier, you're multiplying the bottom by 2. If you go a 12th to the right, then that means you also have to go a 12th to the left. Those are going to be important points for us. Now the other point that's also important is our origin, because that's where it starts. Unless we shift it left or right, up or down. Which, was there any adding or subtracting? No. When we graph the tangent, now here's the part that's going to be important to you as far as what the A does. What number is in the A position? Good. So at the positive pi over 12, what's going to happen is, because my tangent is positive, we're going to go up to and make a dot at that spot. You're going to go and make that dot as high as whatever A is. Okay? So however high A is, that's how far you're going to do that. Okay? You're also going to have a dot on the origin, because after all, that's where we started. And at negative pi over 12, what goes up to on the right-hand side, what do you think is going to happen on the left? It's going to go down, right? 1, 2. Make dot. Now I know it's kind of messy in there, but at least we got the stuff labeled. Maybe we need to put that negative pi over 12 on the top so it's out of the way, huh?
It's okay.
It's okay?
Yeah.
All right. So what do I do with the dots? Connect them. Now, does it look linear? Yeah, and it kind of should through this, even though it's not supposed to be linear. It's supposed to be a smooth curve, if I can smooth curve that at all. Okay, but that's what it's supposed to be. Those are the ordered pairs, or at least the ordered pairs that are important to us. So now when I draw this thing, what happens is if I try to go this way with the curve, what would happen if it hit this wall? Where would it go with that angle? It should go up, right? So it should kind of flow uphill. You kind of make that try to go flowing uphill. What about going the down on the downswing? It just keep going down. Now, just so that you guys understand this, this is 1 period's worth of this graph. And here's how I mean by 1 period's worth. If I have negative pi over 6 on the left and positive pi over 6 on the right, if I add those two distances together, what's 1/6 plus 1/6?
A third.
2/6 or 1/3. Is that what you guys said was the period?
Yeah.
Yeah. Now, the other thing that was also happening in here, because again, your directions are going to be very similar to what you've had all the time. It's going to say, graph 1 period of this, which you've already done. Describe the graph of G as a transformation of the graph of f of x equals the tangent of x. This is something that you guys have done for us since like the first day. What's the 2 tell you in the front?
Vertical stretch or shift.
Vertical stretch by 2. So vertical stretch by 2. What's the 3 tell you? Horizontal shrink by
This is the one that switches, so it's like the 1/3.
yeah, by 1/3, right? You flip it over. Good job. Have you answered the question?
Yes.
Did you do everything that was asked? Yeah. So that period in the vertical asymptote is what's going to help you draw everything. If you didn't notice, just like we did for sine and cosine, we're halving everything, okay, in order to get it. Try to flip it for me?
No.
Oh, I thought you did. All right. Now you guys try.
You touch your book. I don't touch your book. Oh, are you doing it? I touched your book. Oh, it's still here.
No, still tangent. Same
This is
type of
gonna
thing.
this is gonna be the lesson that makes me have to use more than 1 page.
No, it won't be more than 1 page, I promise.
Are you sure? Because I'm already
Okay,
over
so
half.
again, here's what the question's going to be. I need to know what the period is. I need to know the vertical asymptote. Sketch the graph, the transformation. Don't forget, share with each other. Make sure everybody knows what's going on, because you never know who's going to get asked.
Well, I'm gonna get asked.
Oh.
It's gonna do it on this calculator.
I can do it on mine. I remember how to. Well, somewhat. Some won't remember how to. What'd you get for the VA? You're not there yet. Yep. Okay.
You scared me. I'm never fast enough, Jay. You're faster. Okay.
It's just because my brain works like a third of the time, and math is like that third. Pi over, yes.
Why was that a question?
Shut up. Oh, shoot, I put this in the wrong spot.
Tipsy.
Don't stop, just do it. Pi over 8?
Oh, wait. Stuck in my head.
Formidable.
Oh no, that's even worse because I can sing that out loud. Wait, do I go up and press that? Yes.
Okay, I think. So are they watching you for your benefit or for their benefit?
Both. Both. For me.
Will you
and
check
for them.
mine before you choose a group? Because
Oh, you know the calculator chooses. I don't choose one.
I know. Will you look at it, please?
Magic calculator.
What about it?
It's up 3, right? Because 3 is in the A spot.
Okay.
So it's up 3, down 3, and then the origin point, right?
Just blocks away.
That is correct.
Well, you see, that's not cool.
The calculator choose it. Wasn't our group.
It
Ah!
wasn't. BR, what's up?
I think Brittany did alright.
I think you did great.
That's correct, right?
Yeah.
Keep the horizontal string.
Yeah.
Go right on the board. I'm not right on the board.
That's like a first. I was impressed.
Not right on the board. But not right on the board.
Oh, you guys didn't get picked anyway.
I have a question.
What's up? See if these guys know. Kat didn't know why I went up 2 on the last one.
It went up 2 because so you just go like up 2 and then you down 2. So then for this one it's 3.
How we doing? You guys almost done?
Yeah, then you go to the first spot. And then remember in the middle. You put it and then you put it in the middle scales right here.
You got it?
And I think you go
Sure. Your group didn't come up, but if you're willing to do it instead of
Okay,
being on your
no
phone,
one judge me.
absolutely.
No one judge me if it's wrong, okay?
Only I get to judge.
So you want me to write like the period and stuff?
Yep.
Okay.
In math apps, we're watching a movie,
Equals.
so they got to hear it.
Do you want me to do the math with it? No, it's fine.
Huh?
I'm not doing the math with it. Unless you want me to do that. Do you want me to do that?
Yeah.
Whatever, he's not listening, so I'm not going to do it.
Do I want you to what?
Do the math with it, because like it's...
Nope, it's fine what you have. Okay, so Trinity actually requested to do this
Yeah.
one, even though that her group didn't come up. So right now she's got a period of 1/2 pi and a vertical asymptote of pi over 4. How's she doing?
Brady, shut up. Okay.
Judged.
So now I'm going to do the graph. The graph is probably wrong, though.
Okay, so what do you think of the period and the vertical asymptote? Are those good? Yeah, I think so too. I think that's pretty good. Now comes the graph. Bum, bum, bum.
Okay. Do I shut?
Not so far.
I think this is gonna be wrong. Is it pi over 2?
No.
Then it's
A
wrong.
half is not smaller than a fourth.
What is it then? 1/8. It's eighth. It's okay. Am I right?
That's better.
Yeah. Okay, and now you.
Okay, so what she's done is she's made her numbers on there so far. What do you think? Good? Except for, there you go. Now
Shut
she's
up,
got to
Brady.
change those.
Uh,
Keep going.
okay, and then you go up 3.
Why are you going up 3?
Because of the 3 right. A is 3.
A is 3, good.
Oh, let me do this real quick.
Now she's making her boundaries.
And then do you do. Is that right? Okay. Because I knew I had it right now. All right, now I'm gonna write the. Do you want to talk before I? Write?
Nope, you're
Okay.
fine. Now, it's a lot harder on here. I've actually got to witness her picture as compared to the one she drew. Her picture on her page looks a lot better than the one she drew, only because she just didn't really have enough space to make it look more curved.
Yeah.
Okay, so I knew that what she at least attempted at drawing there was kind of what the curve looks like. Okay. We got a vertical stretch of 3, horizontal shrink of a half. What do you guys think?
She killed it.
Not too bad?
Yeah, Brady. Brady.
Let her have her moment.
The negative part, yes, and that if she would have not have fixed that, that would have been the one thing I would have blasted her for.
Yeah.
Which wouldn't have been a big blast, it would have just been a minute.
Brittany just can't have. You have one good one. Brittany, you can't give me credit. You really have to steal my credit. Wait, what's it stretch?
Vertical stretch of 3. Yep. If the number is higher than 1, it's a vertical stretch. If it's less than 1 but greater than 0, like a fraction, then it's a horizontal or vertical shrink.
Now we're going to do cotangent.
Yep. Horizontal stretch is if the number is between 0 and 1, and horizontal shrink if the number is greater than 1. Okay, the next one. We have the cotangent of 1/2 x. And so on this one, we have a cotangent of this one. So now it's just a little bit different. Everything about it, though, starting out is the same. Find the period first. So what is in the B position? A half. So right now I have pi divided by a half. Can you leave it as pi divided by a half? Yes. No. How do you get rid of a half on the bottom? Multiply it by the reciprocal. And the reciprocal of a half is 2. What I do to the bottom, got to do to the top. What's 2 times pi?
2 pi.
2 pi. Now, the vertical asymptote, this one's cotangent, is also pi over b. If you did pi over b already for the period, why do it again? What is the vertical asymptote?
2 pi.
2 pi. It's the same. Okay? Now, the difference between this one and the last one, if we went 2 pi to the left and 2 pi to the right, we would actually be graphing 2 periods worth, not 1. I'm only going to require you to do 1, not 2. So when you draw the cotangent, now make it a little bit longer like we did on the first ones, when we did sine and cosine. And we're going to go over here 2 pi. What's half of 2 pi? Pi. What's half of pi? Bless you. pi over 2. What's halfway between 1 and 2? 3 pi over 2. If those sound familiar to you, they should, after all the times we had to do them using sine and cosine, right? Now, the vertical asymptotes, just so that you know, I'll mark them in red. We went and put a boundary right at 2 pi, and there's a boundary on the y-axis. There's your boundary markers. Because with a cotangent, the vertical asymptote is over the same amount as the period. Okay? Now, for this one, very similar to what we did for the tangent, where we went and the middle is where it crossed. The middle is where it's going to cross here also. So that means at pi, that's where it's going to hit the x-axis, unless you shift it up or down. Okay? Then, instead of going up on the right-hand side and down on the left, it's going to go the opposite. So
is it kind of just like a vertical flip of the...
It's kind of like, exactly. And what Jay said, okay, she asked if it was kind of like a flip over the x-axis. Kind of. Okay, because now it's going to flow downhill instead of uphill. But the other thing is also it's shifted over some too without even having to shift. So now it's going to ride down, hit the 3 dots, and go down towards the bottom. Okay, what do you think? Do you guys want to do one on your own? Or are you guys good? Huh? Do you want another one or not? Okay, so again, the difference between tangent and cotangent. Tangent will flow uphill, and we'll go through the origin today. Cotangents will flow downhill and go halfway between those two things. What we got for you today is page 502. 6 through 12 evens and 16.
Is 16 a word problem?
No.